Hello everyone, I hope all of you are doing good. Okay, today's we will discuss about a very important topic which is called the differential equation. Okay, what is differential equation? First of all, we defined equation. What is equation? Equation is equality. Equation and equality will satisfy the some values of a variable is called equation, because equation is a type of equality. There are two types of equality: one identity and second equation. Identity satisfy all values of variable, but equation doesn't satisfy all values of variable. Okay, now let's go to define the differential equation. Differential equation. An equation which containing dependent variable, independent variable, and differential coefficient of dependent variable with respect to independent variable is called differential coefficient. First of all, we defined three in this differential equation definition in main three things. Okay, first dependent variable, second independent variable, and third differential coefficient. Okay, let's we define what is main things. First, independent variable. Second, dependent variable, and third, differential coefficient. Okay. Independent variable, dependent variable, and differential coefficient. Differential coefficient is dy upon dx, d2y upon dx2, d3y upon dx3, and so on. Okay, this is the differential equation of first order, this is the differential equation of second order, and this is the differential equation of third order. Okay, independent variable. Let's say to know about the independent. Let y equals to sin x. It is a trigonometric function. Okay, we know that the graph of sin x. First of all, we know period range of sin x is -1 to 1, and graph will go to its period is 2 pi. Okay, period is 2 pi, and pi by 2. Okay, pi by 2 and 0. Okay, good. Here, if we will put x equals to 0, then y equals to 0. X equals to 0, then y equals to 0. X equals to 0, then implies that y equals to 0. And put x equals to 1. Sorry, put x equals to pi by 2. X equals to pi by 2, then implies y equals to 1. Here, for different value of x, then we change the value of y. X is dependent on y. Y is dependent on x. For different value of x, then y will get different values. Okay, so here y is dependent variable. Y is dependent variable and x is independent variable. Okay, now then we take a few examples of differential equation. Okay, dy upon dx plus 5y equals to 0. Okay, it is a differential equation. Is it differential equation? Yes, it is differential equation because it contains differential coefficient and dependent variable, but not necessarily the equation is containing dependent variable and independent variable. Okay, it is only if equation containing only differential coefficient, then we can say it is differential equation. Okay, and second, d2y upon dx2 plus c5 dy upon dx plus x equals to 0. It is also a differential equation, okay? But here here more than one differential coefficient, but it is also a differential equation, okay? And third, now what is differential equation? This is differential and this is differential. But dy upon dx equals to a. Is it differential equation? No, it is not differential equation because here is arbitrary constant, not a constant. Arbitrary constant is middle constant, not a exact value, not a constant, not a variable. Okay, it is arbitrary constant. But a differential equation has no arbitrary constant containing. Okay, it is not a differential equation. Okay. Okay, let's go to define two most powerful terms in a differential equation, which is called one thing is order of differential equation, and second thing degree of differential equation. Okay. Okay. What is order of differential equation? Order of differential equation. Okay. Order of differential equation. Highest order derivative is called highest order derivative of that given differential equation is called order of differential equation. Okay. Highest order derivative present in that given differential equation is called order of differential equation. Okay. Highest order derivative present in a given differential equation is called order of differential equation. For example, d2y upon dx2 plus 5 dy upon dx equals to 0. Here, order of this differential coefficient is 1. Order of this differential coefficient is 2. Here, the highest order is 2. Then we can say that the order of that differential this differential equation is 2. Okay. Order equals to 2. And second thing, d2y upon dx2 plus y dx equals to 0. Here it is a sign of integration, but we can say that we can't say that the order of differential equation. First of all, we differentiate both sides. Okay, d2y upon dx2 plus y equals to 0. Here it is free from sign of integration, but it is free from sign of integration. Then we can say that the order of differential equation is 3. Okay, order equals to 3. Okay. Okay. Now let's go to define the degree of differential equation. Okay. What is degree of differential equation? Degree of differential equation, the power of highest order derivative. It means power in this set, power or in this set or exponent. Okay. Degree. Degree of differential equation. Power of highest order derivative. Power of highest order derivative, which is free from radicals radicals and fractions. Fraction which is free from radicals or fraction is called degree of differential equation. Degree of differential equation. For example, first of all, d y upon dx is 6y equals to 0. Here, order of the given differential equation is 1, and power of highest order. This is a power is here. Power is 1. Then degree is 1 because 1 is belongs to natural number. It is free from radicals and fraction. Okay. Let's take second example. D square y upon dx square equals to 1 plus dy upon dx pi by 3. Here we say here the power of differential equation is fraction. First of all, we square we both sides cube. We get 2 dy upon dx to 3 equals to 1 plus dy upon dx power 5 on the power 5. Then here it is free from radicals and fractions. Then highest order derivative here, highest order derivative. Okay, power of highest order derivative 3, and then we can say the degree equals to 3. Okay, so today's we will okay, I will stop here. Okay, bye, thank you.